Hey comrades, here are the circumstances. We were taking our usual journey through our forest of calculus when we stumbled across a vicious, rabid derivative with respect to x of e to the x. And it really ravaged us. We tried handling it mathematically, then we had to resort to non-mathematical means. Abby tried pouring her cup of coffee all over it, that didn't work. Cameron tried pouring his friendliness all over it, that also didn't work. Blake requesting bonus points of it, still nothing happened. Shelby and Ian drew very nauseating pictures for it to, I guess, try to blind it, but still nothing worked in that regard. Will threw his earbuds at it, nothing happened, and finally even Nina gathered all my markers and threw them all at it, and still nothing happened. So that's when it fell into me and my brother. We tried to tackle it and nothing happened. We even unleashed the wrath of Mr. Cookie, but it was all to no avail. So, that's how we know that this is an Avengers level threat. And this calls for one final Hail Mary, Cowboy Barkley. And he's going to have to evolve into Hunter Barkley.
So is this a wild problem or a hunting problem?
Wild isn't enough to convey it, Jordan. This is a universe-ending threat. We're in the end game now. So, I think a good place to start is just with the definition of E. Not E to the X, but just plain old E. Maybe there's some hope in there. Jordan, can you define this for me? Can you remember what it is?
E?
E.
Oh, like the limit?
Yes, do you remember what that limit was by chance?
It was limit as n approaches infinity of 1 plus 1 over n, all to the n power.
Yes. And I know I can refashion that limit into an equivalent limit as the limit. I think this is going to work. N approaches 0. I'm going to keep that 1 there. And I know I can replace that 1 over n then with n. And then instead of raising this to n power, I can raise it to the...
To the 1 over n?
Yes. Yes, and also, no, I think here, n approaching 0 also works for both left and right. Because the graph of this thing, it's coming back to me. Has a hole right there, but it extends left and right. And this is the graph of
Y equals e to the x.
No, just that guy, but I'm going to replace the ends with x's. I know this graph looks like that, so this limit works from both left and right as it approaches 0.
Okay.
But no, I'm going to work with this guy here.
Okay.
Just because 0 is easier to work with in general than infinity, I feel. Let's see if there's a ray of hope in this. Okay, how can I start this? I gotta fall back on my limit definition. Limit, so h approaches 0, of e to the x plus h. I think what comes next is
Is e to the x over h squared, or just h?
just h. Okay. Just h. And this guy, I can break that up into ex, eh, and for both this and this, I have one in common.
E to the x.
E to the x, and this whole thing is just varying with h. So as far as h is concerned, this guy and this guy are
Factors.
constants, yeah,
Constants,
just constants. So I have e to the x times the limit of e to the h minus 1 over h. Is there anything I could do with that? Maybe. If I call that numerator, if I just say the numerator is n, is this enough to get me somewhere? Let's see. So if that's true, then n plus 1 is e to the h. And now I think I can get an expression for h, yes? What do I have to do to both sides?
Take the natural log of both sides.
Yes. Natural log of
n plus 1.
N plus 1. Okay, I think I'm getting somewhere because now I can express this whole fraction in terms of n as opposed to h.
Okay.
And another thing, as h goes to 0, as h goes to 0 and how I've defined n, what is n approaching?
N would also approach 0.
Okay. Yeah, so h going to 0 implies that n has to go to 0, yes?
Yeah. Because e to the 0 is 1 and 1 minus 1 is 0.
Okay. I think if I work with this guy, which I've solved for in terms of n, I got h on one side. If I let n go to 0, as n approaches 0 from both left and right, what does h approach?
ln of 1, which is 0.
Exactly, ln of 1, which is just 0. So putting these two fellows together, I have a logical equivalence. H approaches 0 is logically equivalent to n approaching 0. And armed with those facts, this, and this, I can rewrite this entire limit, I think, as e to the x times, instead of the limit as h approaching 0, I know I can write that as n approaches 0. All over n times, or divided by a natural log of n plus 1. I have that. I have that much. We have something to hold on to.
So how'd you get n on the numerator again? Just n?
So my hope here, I'm just calling the numerator n.
Okay.
Those three dashes means I'm just defining it to be that expression.
Gotcha.
Yes?
Yes.
Cool. Great. Wonderful. Relatively speaking, of course.
Okay, it makes sense. Yeah.
And now, maybe, there's some hope in taking this n and sticking it in the bottom as 1 over n.
That's an n, not an h, right?
Yeah. Well, these are all n's.
Okay.
N and 1. Now, I have something times a log. When I have that situation, is there anything I can do?
You can say that's ln of n plus 1 all to the 1 over n power.
All to the 1 over n power. Okay, great. So I'm going to create some space here. Like so?
Yes.
Like so. Okay. Now I wonder if I can do this. If I can take that limit, put it in the top and the bottom to migrate it. Good. Limit as n goes to 0 at the top is just 1. And the limit of the bottom. I wonder if there's anything I can do with that. Perhaps this would work. Perhaps this will do the trick. Or get us somewhere. Get us one step further. There was that thing called the composite limit theorem. Which says that if we have two functions f and g, if how did this go? How did this go? If the limit as x approaches a of g of x is b, and if f of x is continuous at b, it's continuous at b, then that limit on the outside I can bring that into my composition. So that's f of the limit as x approaches a of g of x.
In what course is this composite limit theorem taught in?
This should be taught in calculus.
Okay.
It's often not, because people just think it might not be of much use, but I can't see of any other better hope for this problem at this point than to maybe take this limit here and stick it on the inside of this guy.
Okay, so we should do that.
We should try.
Yeah.
We should at the very least, it deserves a shot. Because we've tried everything else. We've tried coffee, we've tried gentlemanly friendliness, we've tried it all. We've tried cookie. So composite limit theorem and cowboy hat. Let's see how they fare. Oh boy, okay, so let's say if let's say f of x is the natural log of x, and g of x is x plus 1 to the 1 over x. You know what, I'm going to change it, just a letter change, just to keep it in keeping with what we've been doing. Say f of n, n. What is the limit as n approaches 0 of g of n? If g of n is defined to be 1 plus n to the 1 over n. Oh, maybe, yes. 1 plus n to the 1 over n, the limit, that's just the definition of e.
Okay.
That's the definition of e. Now the question is f of n, is that thing continuous at n equals e? Is ln of e, is it defined and is it,
ln of e is just 1.
Yeah, I mean the graph of that thing, remind me, graph of a natural log looks something like, like so, yes? Mm-hmm. It hits the x-axis at 1 and e 1, so yeah, it's continuous. Well, if that's the case, if that's the, and there it is. And there it is. There we have it. This thing, I just did the problem here. My f of n is this entire thing, natural log of this stuff. My stuff on the inside is g of x. Therefore, this thing is 1 over the natural log.
The
Limit as n goes to 0 of n plus 1 to the 1 over n.
So
This is the definition of
e.
The definition of e. Natural log of e. Mr. Jordan,
Yes.
what is the natural log of e?
It's just 1.
It is 1!
Yes.
Exactly. So we have e to the x times 1 over 1, which is,
e to the x.
that is the derivative of e to the x. A famous man once said, a famous writer said, we'll know ourselves, we'll know the beginning when we arrive at the end. And I can think of no better mathematical illustration of that than this. We know the beginning when we arrive at the end. We know ourselves because we are the beginning and the end. So there it is. There is my derivative
Brilliant.
of e to the x. It's just itself. I mean, what this means, think of this geometrically. My gosh. It's an exponential, of course. There's so many exponentials. But imagine that this y-coordinate was, I don't know, let's say 88. What does that mean the slope here has to be?
88.
The slope itself is 88.
It's basically a derivative graph.
Yeah, its graph is its derivative. It's reporting on the slope of itself.
Oh, that's pretty neat.
Pretty neat.
Pretty neat.
It's beyond wild. It's apocalyptic, but in the good way. Ah! What the Scooby-Doo bop is that? The son has come to avenge his father. This is not just any A. This is any A. That's what makes it so bad. It's any any positive real number. No matter how wicked the sun is, the apple doesn't fall too far from the tree.
It's gotta be close to eat.
We've dealt with the tree, my friend.
Okay.
We have dealt with the tree.
Now it's just time for the apples.
Now it's just time to harvest the apples. Exactly. Yes, good. Yes, sir. Yes, sir. We're gonna keep it real here. Oh, jeez. Someone remind me, what is this equal to? Scream it from the rooftop, scream it from the top of the trees.
Let's see.
What the heck was that? You call that a scream?
Yes.
You, sir?
C.
Okay. C. Alright. How about this? Now, try screaming this. Speak from your soul. What about R times any general log of b to the x? How can I write that?
Log of b to the x to the r.
Yes, sirree.
Is that a better scream?
That'll do the trick. Okay. We need to be more epic than this. And we will. And if you're all willing to join my epicness, I will carry the load for the both of us. I will carry the load for the both of us.
Captain.
What this means, this a to the x, forget about this bloody derivative for a second. I can write that as e to the natural log of a to the x.
Okay.
That's using rule number 1. Rule number 2.
Using both at the same time?
Exactly.
It's dangerous.
It's dangerous, but that's what makes it so fun. E to the x times natural log of a. In other words, I am raising e to a power. One single power. How could I do this? How could I find the derivative of e to the x times the natural log of a, but all with respect to x? I see where it is. All I have to do is do the chain rule. I do a little number like so. Scooby-doo bop bop, hippity bop bop bop. I just take that with respect to what? Whatever that is, right?
Yes.
So x ln of a times that chain rule. Chain rule, you've got to love it.
ln of a is a constant, yes.
Yes.
Okay.
So that guy equals?
Just ln of a.
Just ln of a. And this first piece equals?
Just e to the x times ln a. E to the x ln a.
Yes, e to the x ln a. So,
when it comes to notation, would it be e to the x ln a or e to the ln a of x? Does it matter?
they both mean the same thing.
Okay, I know. Yeah.
But, in the interest of getting it into its most simplified form, your second option was the right one. This guy I can rewrite as e ln of a to the
x.
To the x. I multiply that by the natural log of a. And what happened to this e and this natural log?
That becomes 1, basically.
Yeah, not 1. This ln of a to the x is the power that turns e into a to the x.
A to the x, yes.
So if I'm raising e to the power that turns e into a to the x,
that whole thing becomes a to the x.
A to the x by good deduction, yes sirree. And we have a to the x times the natural log of a.
Well, that was a lot easier. Nice. Is that a Thanos snap? Nice. Are we done?
Yeah, we're done.
Okay. I'll definitely end the video with like the Thanos dissolve effect.